Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, you're gonna look at a work question number 2 from the exam. Yeah, from the exam question. Now, let's hear. It says to us, learners conducted an experiment to determine how the initial kinetic energy given to a trolley affects the distance the trolley moves on a rough horizontal surface. Here, rough horizontal surface, they are telling us there is friction without telling us. All right. A learner pushes a trolley of unknown mass until it reaches point A. So, all right, until it reaches point A with kinetic energy EK. So, before the experiment started, the trolley was given was pushed rather so that it can have a kinetic energy. But after reaching point A, they started the experiment until it went on further. Take note of that. Why? This is to make sure that you have to understand that the experiment started when the trolley reaches point A, when there was no other force applied on it. Because now, remember, we are trying to make sure that we get the aim correct. Remember, the aim is to determine how initial kinetic energy given to a trolley affects the distance. So we do not want to have any force applied that will affect our results. So we want to see at point A, now that an object it is moving on its own with that kinetic energy, how does it affect the the change in x, on whether when the object has a higher kinetic energy the distance becomes longer, or when the kinetic energy is low is higher the distance is shorter. Whatever the case, remember you're experimenting here. All right. The horizontal distance change in x traveled by the trolley be, hmm, by the trolley before it comes to rest is then measured. Again, yes, before it comes to rest, somewhere is going to come to rest, we don't know where. Now, we are told that the experiment is repeated with the trolley moving on the same rough horizontal surface but with different kinetic energy at point A. Hence, I'm saying from point A, when our trolley reaches point A, that's when we start our experiment. Now, it means now, on our first attempt, maybe they give it a, a force of 10 newtons. On our second attempt, they give it a force of 20 newtons. This will affect the kinetic energy they offer, okay? But we are not interested in that. Now, we are told that the experiment is repeated with different kinetic energies at point A so that we can improve the reliability of the experiment. Now I'm talking life sciences. This is life sciences energy. You repeat the experiment, you increase the sample space. We are not there. We are doing physical science here. Now, all right, let's see. The results obtained are shown in the diagram. So the results obtained here will show us now what, all right, it is moving. Let's see, let's try to interpret a little bit this result we get. So we have a distance of 0 traveled here. Again, so when our object has a kinetic energy of 6, it means it is traveling a distance of 1,5. Let me show you. If our object came here with a kinetic energy of 6 joules, then it means this distance traveled, it is gonna be 1,5 meters for the first try. On the second try, here this one tells us, or if it had no zero, if it had zero kinetic energy, it traveled no distance. Obvious. If you do not have any kinetic energy, you cannot move. Our second attempt was that it was given an initial kinetic energy of 12. Now, this is our first try. Second try, it was given a kinetic energy of 12 joules. Now, if you are given a kinetic energy of 12 joules, now you have what? You have more energy to travel a higher or a longer distance. So, we are told that it is going to travel a change in x of how much, of 3 meters. This makes sense because now when you have more energy you can cover a more distance, you can do more homeworks, you can watch more videos on YouTube. All right, yes. Now, the last one, experiment 3, we have 18 joules, it travels 4,5 meters. I hope what I'm explaining here is clear. Or I hope what I'm explaining here is clear. So this is gonna be the kinetic energy initial, initial, initial. If you use this kind of when calculating in calculations, when you use this kinetic energy here, it means you have to use this distance here. But if you decide to use this kinetic energy here, you have to use this distance here. So you do not need you do not need to make this mistake of saying you use this kinetic energy, but you use that distance travel. It does not make sense. The data is not saying that. So don't try to come with your own data here. We are gonna penalize you and you'll get your answers incorrect. Now, ignore the rotational effects of the wheel. So basically, whatever the DI, never mind the statement. Never mind. So we are trying to say ignore other frictions except for the friction that you are given. So 5.1 says to us, draw a labeled free body diagram showing all forces acting on the trolley during its motion after passing point A. After passing point A, this is very important. 5.1. 5.1. Free body diagram. Remember what I always say, FG. It is what you are always going to draw. It is always there. FG. Then we have what? Normal force. This is skewed. And now we have friction. Now our object is moving in that direction. So our friction is going to oppose the motion. We are told it is moving on a rough surface. Again, yes, this is your easy 3 max. This is your easy 3 max. 5.2. Name the independent variable in this experiment. The independent variable. Now, the independent variable is a variable that does not depend on anything. Now, let's see. Let's see. Now, we have what? We have, what's this? All right, let's come to our aim. Our aim is to determine how the kinetic energy given to an trolley affects the distance the trolley moves on a rough horizontal surface. Now, on your aim it is normally based like this. It is giving you to like this. Determine how the independent affects your dependent. Always like this. Your question, if you know how to find your aim, you will see your information. Now let me erase this so that we can identify. Here our aim starts here. Determine how the independent. Determine how the independent. How the independent given to an object, to a trolley affects the what? The dependent. Banna. I believe you are following. Affects the dependent. The what? The trolley has. The trolley moves on the rough horizontal surface. So now we have our independent here affecting our what? Our dependent. So I believe you know the answer. The answer should be what? Initial kinetic energy here. 5.2. Initial kinetic energy. 5.2. You can say kinetic energy, but you just say initial what? Kinetic energy. This also applies also on life sciences when you are asked to determine the dependent, the independent, the controlled variable thereof. So let's move on to 5.3. 5.3, it is a stating. State is you should state work energy theorem, easy 2 marks. Level 1 question, easy 2 marks. Let's define. Remember what's formula for work energy theorem? It's like this. W net, it is equal to change in K. You can get your definition from this part. Now let's define it. 5.2 5.3 rather. Work energy theorem states that the network done on an object is equal to the change in kinetic energy. Kinetic energy of an object. Now, from the formula, W net, it is equal to change in K. Now, we are saying the network here, the network done on an object is equal to the what? To the change in kinetic energy of an object. Easy to marks. Easy straight to marks. Now, let's look at the last question, which is 5.4. 5.4 says to us, calculate the mass of the trolley if the coefficient of kinetic friction between the wheel of the trolley and the rough surface is 0.18. Now we are given mu k as 0.18. Now do not be scared of, oh, how am I gonna start about this one and what? Just apply what you know. Oh, another thing I have to mention. Normally the examiner likes to do this. The examiner likes to say, state something. Ne? Whatever that you're gonna state is what the examiner requires you to use. 99 point, let me say 95% of the time. This is what the examiner is required you to use. W net, it is equal to change in K. You can never go wrong with this formula. I repeat, you will never. Now let's use what the examiner has asked us to define. So in 5 point, I think it's 5.4. Let's use W net, it is equal to change in K. Now, what is our W net? It is work done. Remember, W net include all the forces acting on an object. But now, in this case, it is only friction. Again, they have half mv squared final minus half mv squared initial. All right. Now, I want you to take note of something. The initial initial kinetic energy you are given from the information. It is a matter of you choosing which one you are going to use. Again, so let's say we have here, it's going to be friction changing x cosine of my angle. It is equal to half mv squared final minus half mv squared initial. We will substitute, do not worry. But now we are told that we have a mu k. Remember, information cannot be given without the examiner cannot give you an information that you will never use. So if the examiner gives you a kinetic mu k, so remember that friction, it is equal, let's say fk, it is equal to mu k multiplied by normal force. We know that again. So we can substitute in place of friction and say this is mu k multiplied by the normal force. But now, all right, let me do this. Friction, it is equal to mu, let me say fk, mu k multiplied by normal force, which is equal to mu k. But I know what is normal force. Normal force, it is mg in this case. Normal force, it is equal to mg in this case. Again, yes. So I might, instead of substituting normal force, and substitute what? Mg. Changing x cosine of my angle. Therefore, half mv squared. Someone is asking, oh, Abuti, why aren't you substituting already? I want you to understand first before you substitute. Now, let's substitute. What is our mu k? Our mu k, it is 0.18. What is our mg? Let me do this. Multiply, what is our mg? Our mg, it is mass we do not have, it is unknown, we are calculating it. What is our gravitational acceleration? Which is 9.8. Changing x, your changing x will depend. This one is a matter of you choosing. If you choose this changing x, it means you have to choose this change in kinetic energy as 6. If you use 3 as your change in x, it means you should use 12 as your kinetic energy. If you use 4.5 as your change in x, it means you should use what? 18 as your kinetic energy. Very important. I'll use 3. My change in x is 3. I don't know why. I feel like it. I'll use my change in x as 3. Then cosine of 180, it is moving in an opposite direction. Again, then half, mass is unknown. Mass is unknown. Now, what is my final velocity? My final velocity is 0. Why? Because here, let's look at the statement. Starting from here, the horizontal distance change in x traveled by the trolley before it comes to rest. Before it comes to rest. And we know if it comes to rest, somewhere, somehow, our final velocity, it is 0 meters per second. So here, I'm going to have 0. 0 squared minus, I used 3. So I should use a corresponding kinetic energy to 3, which is how much? Which is 12. Then I do my mathematical gymnastics. This one, hey, do I need a calculator? Let's see. I know cosine of 180 is -1. That one I know for sure. That cos of 180, it is how much? It is -1. But now, what is 3 multiplied by 9,8 multiplied by 0,18? In that case, it gives us 5. Remember, I'm saying 0,18 multiplied by 9,8 multiplied by 3 multiplied by -1 multiplied by m. This is simple algebra. So it's going to be negative due to cos 108. Negative what? 0,18 multiplied by 9,8 multiplied by 3. I'm Eminem. All right, it is 5,292 m. It is equal to, this is 0. 0 minus 12, it is -12. Then you know, I don't like doing this. You know you should divide both sides by what? By Nope. Oh, yes. You should divide. I thought this answer was going to give us negative, but I just realized it is negative here and negative there. All right. So it's going to be 12 divided by 5,292, which gives us how much? 2,2675, but into 2 decimals is 2,227. 2,27 what? Remember, this is physical science. In physical science, you use kilogram. In chemistry, you use grams. I still repeat. So yeah, that's all you are required to do. How do they mark this? Your formulas are, this is your manipulation, Chem. This is your manipulation. You still haven't got a mark. You just get 1 mark. For substituting 3 here and substituting 12, it is a mark. For substituting what? These in how much is this? Or 6 marks. For you realizing that this is mu k, mu k normal force, which is mu k whatever there, you get a mark here. Then for substitution on this side, you get a mark for 3, you get a mark for the substitution, which is 1, 2, 3, 4, 5 marks. Then your final answer, it is 6 marks. What's important is understanding the concept. I think I'm done. Even if you were to use 3, even if you were to use 0.5 as well as 6, you'll still get the same answer. So thank you very much, folks, for watching my YouTube video today on work, energy, and power. Video number 3 under questions, but video number 2 under exam questions, excluding multiple choice question. So thank you very much, folks. If you enjoyed, please give it a thumbs up and kindly subscribe to our YouTube channel. Thank you very much.